So hello everyone, this is lecture 10 for the atomic physics. In the last lecture we were discussing about the spin orbit interactions and we were discussing some questions. So today also we're going to discuss some more questions. So here we have the spin orbit interaction in sodium produces D1 and D2 lines with wavelengths 5896 angstrom, 5890 angstrom respectively. Calculate the internal magnetic field due to the electron orbital motion. So this kind of spreading is there for the sodium produces, that is 2p. It will divide to 2p 3 by 2, 2p 1 by 2, and two lines we are getting for this transition. Because of this splitting we are getting two lines d1 d2 means 5890 will be for this, because larger the energy gap, minimum is the wavelength, and smaller is the energy gap, maximum is the wavelength. That's why you are getting these two lines. So we need to calculate the magnetic field due to the orbital motion. So see, we will calculate by two methods. The delta E means this energy gap, and we just equate that. So delta E you need to find, and that will be, for this one it will be SC by lambda 1 minus SC by lambda 2. So this minus this will give you this energy gap. This will be like this. So this is a one way. Now we have this value. Now we will see the interaction, and see, you must remember this value HC directly, 1.24 into 10 to the minus 4. You must remember this directly. Now we need to calculate this, as we find that there will be shift. So we already know that potential energy difference will be mu s dot b in. This is magnetic moment and this is internal magnetic field produced by the orbital motion. So see, because of this splitting is due to the parallel and the anti-parallel spin, so that's why we'll take the z component, mu s z. So we know this is nothing but gs e by 2m sz b internal, and here this sz is nothing but ms h cut, and this gs will be 2 will cancel out, and it will be ms will give you plus minus half value, and this will be like this, means e h cut by 2m will give you mu b, and gs will be 2 and it is b turn, and ms will give you plus minus half. Now see, you will see here it will be plus minus mu b in turn. Now difference you need to find, because this is the two energy levels it is given by this. So difference will be simply mu b in minus mu b in, it will give you 2 mu b in. So this will be your delta E. Now just equate this with this energy gap, and you can find the B inter value, that will be 18.5 into 10 to the minus 3 Tesla. So that's how you can just simply follow the hint or given in the question. Just follow the question, you will get the answer. So this is one more question. An electron in a particular state of hydrogen atom has a magnetic potential energy of about 10 to the minus 23 joule. So magnetic potential energy is given. Estimate the magnitude of the magnetic field acting on the spin. Magnetic moment of electron, which is order of 1 Bohr magneton. So magnetic moment of a spin is given. So that is mu is given, and mu dot b is simply potential energy, you know, and potential energy is given 10 to the minus 23, and mu is nothing but mu is s is simply mu b, 1 mu b it is given. So we'll just substitute here and calculate the b in. This will be your answer. In a doublet splitting of first excited state, so it will be 2p 3 by 2, 2p 1 by 2 of hydrogen atom. So there is a splitting for hydrogen atom, excited hydrogen atom, and the energy difference it came out to be 4.53 into 10 to the minus 5 electron volt. So calculate the corresponding separation for lithium plus in centimeter inverse. So it is given for hydrogen, we need to calculate for the lithium. Now as you remember, when we calculate the splitting and splitting of energy, and you find this delta E formula, that is AL plus half h cut square. So here this A, that constant, is simply proportional to the z to the 4, means here you can see, when we just find this, this was your A, and this A is proportional to z to the 4, and as you are having here in the question, both will be P. So for hydrogen and lithium, it will remain same, L will remain same, that is 1. That's why L component will cancel out, and this A is simply proportional, or energy is proportional to z to the 4. Other terms will be cancelled out when we find the ratio. It will be delta E lithium divided by delta E hydrogen. Simply Z for the lithium, that will be 3, 4 and 1, 4. From here you can calculate for the lithium, that will be simply delta EH multiply this. Now see, they told you to calculate in the centimeter inverse. So what is this thing? It's called the term value, means you have this energy. Now if you divide it by the SC, the answer will be in the centimeter inverse or length inverse. Means here you have this delta equal to SC by lambda, that is energy, but when this SC will came this side, this whole value will become simply centimeter inverse. So when you write the energy in terms of this is called the term value, and we denote it by the mu bar. So that is the term value. So they ask you calculate the corresponding separation of lithium in centimeter inverse. So when you find the energy, just simply divide it by the SC, and that's why I told you to remember this value of Sc, that is 1.24 will be 10 square minus 4 electron volt centimeter. Now next question is this, similar to the last question. If doublet splitting of first exercise state is this for helium plus ion, calculate separation for hydrogen. So for helium it is given in the centimeter inverse, and we need to calculate for the hydrogen in electron volt this time. So we know this is your term value for the hydrogen helium, it is proportional to Z4. So for hydrogen 1,4, helium 2,4, and you can find you can find for the hydrogen, that will be 5.84, that is given, divided by 16, and here you get this value in the centimeter inverse. Now this is nothing but delta E by Sc, so delta E will be simply Sc multiplied this value. So just put the value of Sc and you will get the answer in the electron volt. Now next question is, a beam of helium ion enters a uniform B 1.2 Tesla. Find energy difference between the electron whose spins are parallel and antiparallel. Also find the wavelength of the radiation that can cause the electron whose spins are parallel to the field to flip to make antiparallel. So it is B is given. We need to find the energy difference between the two spins. So that was simply delta equal to mu BB. We just find this value here. This was this, and this will remain same. So we just substitute the value and we can find the answer. So delta E will be 2 mu BB. So just put the value of mu B and B, that is 1.2 Tesla. And you can find the energy difference, and corresponding to this energy, the wavelength will be given by that wavelength will be needed to flip the make it anti-parallel, means parallel will come anti-parallel. Corresponding to this energy, the wavelength will be given by Sc by delta E. So that will be your wavelength required. Now next question is, the spin orbit effect splits the 2p 2s transition. Lambda will remain same in lithium into two lines with separation of delta lambda 0.14 angstrom. So there was this 2s level and 2p level, and there was this wavelength difference in 2p 2s is simply 6521 angstrom. Means if there was energy corresponding to that, will give you wavelength 6521 for lithium. And now this 2p, this 2s, 2p will split into 2, and delta lambda for these 2 and 2s will be 0.14 angstrom. Corresponding energy difference between two lines is, now the energy difference between these two lines means 2s 2p, and this divide, and the energy difference is this is given by m multiplied 10 to the minus 5 electron volt. We need to find the value of m. So see, you will proceed this way for this question. Here h is given in terms of the electron volt second, that is 4.125 10 to the minus 15. So E is simply Sc by lambda. So dE will be means mod of dE will be Sc by lambda square d lambda. Now d lambda is given, that is this. I need to find the dE, so simply just substitute the value of Sc, and lambda will be 6521 angstrom, and you can find the energy difference between the splitted lines. So you can directly use this. Now this is very important question, last question for today. Doublet component of sodium are shown below. Calculate this figure was given, and this ESO energy is given, particularly this formula was given. Calculate the spin orbit constant for, this is your spin orbit constant ASO for 2p level, and also determine E naught. So we need to find this E naught and we need to find this ASO. So what will this? There will be these two lines you are getting, and this is your two levels which is splitted. Now see what is delta E means. We find it this formula. Delta E was A L plus half h cut square, and this A was this whole thing. Now see, if we just put A h cut square as simply ASO, so means here also this was your formula for the potential or the energy. So it was A by 2 h cut square was also there, but here in this question, as you will see, there is no h cut square is given. So A h cut square is simply written as ASO. So as we find here from this formula in the last, that this will be your energy difference A L plus half h cut square. So A h cut square can be simply written as ASO and L plus half. So this will be your energy difference ASO L plus half. That's how I written this. Now for L it will be 1, and this is given for P, so it will be 3 by 2 ASO. So this will be your energy difference. Now as we find here for these two wavelengths, we can find means Sc by lambda 1 for this one, Sc by lambda 2 for this one, and difference will give you this energy gap. Now find from that formula and equate it to this value, and you can find the value of ASO, that will be this value. Now see, they ask you one more thing, this E naught. So how you can find this E naught? So this will be, first this difference is simply Sc by lambda 2 if this is your lambda 2, and then you need to find this value. So this is downshift. So this downshift value from here, as we calculated, this was minus a by 2 L plus half h squared square. So this h squared square is simply ASO. So it will be ASO divided by 2 L plus 1. So this was your value. So h squared square divided by 2 L plus 1. Now here L is simply 1. So 1 plus 1 2. 2 will cancel out. h squared square is simply ASO. So this downshift will be ASO. So this difference you find, that is ASO plus this is your SC by lambda 2. So this will be your answer. Simply substitute the value of ASO from here and lambda 2 and put the value of SC, and you will get your this E naught value. This is your answer. So that's all for today. Thank you everyone.